D-Lab, everyone. On the bench, we have a newly arrived Fender Blackface Bassman. Has no output. As a matter of fact, the owner said he saw a flash come out of the back of it, so it should be pretty interesting. But before I get to that, I got a goodie box in the mail the other day from my friends at MojoTone. It looks like they sent me an amplifier chassis stand. Okay? Now, you know I have an old homebrew one. They spotted that. I said, well, we'd really like to see you repair an amp on one of our stands. Let's take a look. I've seen these on the website. Pretty cool. All wood construction. There she is. MojoTone emblem. Better watch it. You know me, I'll damage it trying to get it out of here. It's got that foam fill. Alright, there's some hardware in here. I'll get this thing out of the box. We'll put it together and then we'll put the Bassman on it. Well, there's the stand on Mojo's website. Okay, so they call it the Mojo Amplifier Chassis Stand. I've got it sitting on my bench. And I've got the side rails set as they show in their picture. Okay, so you envision your amp sitting on the stand. You're going to want these tabs facing forward so you can tilt it and it doesn't fall off on the floor, right? So it looks like the installation is pretty easy. Just got a bag of what appears to be some T-nuts with some thumb screws. Pop this together and I get that Blackface Bassman up on it. Very nice. Smells good too. Always like the smell of fresh wood. I don't know if they make these to order, but this one smells like she's hot off the press. Very nice of these guys to send this up. I was actually going to pick one up initially. And my friend made me the homebrew one. I figured that's probably good enough, but now I got the real thing. And there she is, assembled. I've got these sides a little bit loose so that I can cradle in the amp. So here we go. First time I've used it. Let's see if I got my estimation correct. Pretty close. And there we are. Tighten up everything. We are ready to repair with a Mojo stand. Well, it is slick. I gotta say, it looks a lot nicer than my old homebrewer. This is gonna be great, and being able to tilt it, let me try that real quick. Yeah, see, that's gonna be nice. Alright, cool. Well, let me put this on the other bench, and I'll show you what needs to be done to the Bassman. Well, there she is on the main D-Lab bench. Really like the nice rounded corners. You don't poke yourself as easy. And one thing I noticed right off the bat is they got these cool little rectangular areas here to put like your tubes and the screws to the cabinets. I usually have like a Dixie cup or a little bowl from the wife's kitchen, make her mad at me, to keep all that stuff in place when I'm working on the amp. So now it gives me a way to be better organized. So they put a lot of thought into this apparatus. I'm really liking it. On the Bassman, I want to show you top side first. So I'm going to flip this thing over, explain what was going on. I believe I know what's causing the problem. So there are things I'm going to do first before I even power this thing up. So as I stated earlier, the customer's complaint was he was playing the amp. After about an hour or so, he saw a flash from the rear and she went out. So rather than messing around with it, he packed it up and shipped it to me. On my initial inspection, I found the power fuse was open. This power fuse, you can see, doesn't have like a big black blast mark in it, so it wasn't a direct short, but something pulled overcurrent causing that fuse to clear. So I thought, okay, let's take a look at the filter caps, make sure that they're new, not the old crusty leaky ones, right? And these have been replaced with some nice sprays, so that's a good thing. And I thought, well, what's the other thing that could draw excessive current but not be a direct short? And that would be the output tubes. So I put these guys immediately on my tube checker. One of them is wide open, absolutely no current flow. The other one's up around 47 milliamps. So something caused one tube to cook. And I think I know what it is. So if you take your tube, pull the old alligator jaws down, put him in the socket, I noticed there's not much tension there, okay? I believe the other one's the same way. So these tube sockets have seen better days, right? There's probably been a lot of insertions and extractions, and over the years the contacts spread, so you do not get a good bite on the pins. So what I believe has happened is one of the tubes lost the negative voltage, so it wasn't holding the current constant. She went warp drive, fried itself, pop, right? And we see the result. So the first thing I'm going to do, like these little compartments, I have my last set of the original surface mount Fender sockets. So we are going to change the sockets, and I have a fresh set of 6L6s. We'll ensure the negative bias is where it should be. There are some current shunts in here. I'll show you that when we do the bottom side inspection. So I'll be able to monitor the current. But I believe all this amp really needs is new sockets, new tubes, and maybe just a general cleanup, because there is a little bit of corrosion and what appears to be some arc marks underneath one of those tube sockets. So let's go bottom side. Alright, bottom side tour. We'll start off with the output tubes back here. I don't know if you can see it too well, but there's some kind of soot. I don't know if that's corrosion or if there's been arcing going on. You can also see evidence that there used to be solder on these back pins. So I believe it used to have little grid stop resistors across there, and those have been removed. The 470 ohm resistors that you'd normally see here on the screens have been replaced with some 510 ohm resistors. Probably close enough for screen circuits, but I'll make sure to check these. Also, you'll see there's some of the 1 ohm current shunts installed, which is nice because when I put in the new tubes, it'd be real easy to check the bias. Okay, the other thing I spotted I thought was odd are these caps. These are the grid coupling caps, right? So they're in line going to pin 5 of the 6L6s. I've never seen any like this. Maybe there's some real high-end caps, but I'm not sure of those. I'll have to measure bias voltages, make sure that there's no leakage there, because that could also take out your output tubes. Other than that, there's some Mallory's. It looks nice, and some Spragues here. She looks pretty good. Whoever did this work did a good job on the recap. And I did also notice the negative bias cap has been changed. So first thing I'll do is change these sockets, then we'll power up the amp, make sure voltages are where they should be, and we'll install new tubes. Here's an update on those screen resistors. Remember I said they're 510 ohms? Not that one, she's 864. This one's 865. So unless I'm misreading this, these guys are way out of tolerance, so I'll be replacing them too. So you can see I'm able to work on this chassis in almost a vertical fashion, which is really cool because now I can get to the hardware on the back of the socket, get to the parts on the front, and you can see what I'm doing without having to have a camera overhead like I did in the past. Okay, so that's very nice. So since these guys are toast, I'm just going to cut them out of my way. Man, they don't really show any signs of heating I'm really shocked that they're that far out of tolerance. This looks like a gold band, so you would think it would try to stay within that 5 to 10% window, but obviously not. Alright, so I'm going to do one of these at a time, and that will leave me a little road map so I can't screw it up. And yeah guys, sometimes I do mess up, okay? Everybody does. So, you know, luckily Fender just sticks their wires through the tube socket holes, so they come out of here pretty easily. I will be wrapping mine around, get a little bit better mechanical connection when we install the new sockets. Okay, the only ones left are the old baked filament lines. So you got to be a little bit cautious when you're dealing with these old cooked wires. Sometimes, since this is solid conductor wire, they can get kind of brittle. These popped right off. Good deal. Alright, let me get my screwdriver on the back side. We'll get the socket out of here and put the new one in. So I was able to flip the chassis right over. Nice to have some stability when you're working on this stuff, because the last thing that you want to do is be working on a customer's amp and have the thing go over on the floor. That reminds me of a little story. You guys might like this. So when I was in the Air Force, I was out at Vandenberg Air Force Base in California, and there's a little town just south of there called Lompoc. Okay, and I worked in it was a TV video repair shop at the time, because back then VCRs and of course TVs are pretty popular, and they're the old CRT type televisions, so they're kind of heavy. Well, this place I was working at was called Elmer's Paint and TV. Okay, this guy was like 150 years old, really cool guy, but he was actually just a painter, and the electronics repair was kind of a sideline. So the whole place is full of like those big 5-gallon paint jugs, you know, the pails. And we would do the repair of the TVs on top of the paint pails. And one day I was there working, I heard this horrible crash. And I looked over, and a customer's TV had fallen off of his paint buckets, and it just blew up on the floor. And I looked at the guy, and he just looked at me. He's like, "Oh well, things happen," and he walked off like nothing, like no big deal. I'd have a heart attack if that was a TV in my shop. All right, let's get this thing wired. So I am going to reinstall the 1.5K grid resistors on these 6L6 sockets. I think it's a good idea, and if you look at all Fender schematics, they incorporated that, so it's in there for a reason. So in this case, the wire that used to go direct to pin 5 will now go over here and go to pin 1. Alright, we'll do the same thing over here when we get to that. Remember, the 1 ohm resistor went to pin 8, which is right here. Okay, now you got to be kind of careful on these tube sockets, because I noticed looking at them that even though this is pin 1, you can tell by the position of the keyway. So there's 1, 2, and 7, of course, will be your filaments. This one here is 8. But if you look on this side of it, it says it's 7. And if you look on this side of 1, it says it's 8. So you got to pay very close attention to where you're putting your leads, because if you get it wrong, you're going to cause some damage. Yeah, so I just noticed that I had my little grid resistor on the wrong pin. Told you guys how easy that is to happen. So remember, pin 8 has 1 ohm resistor to ground, 7 is filament, this is 6 here, 5, 4, 3, 2, 1. Got to be very careful, okay? You know, the worst case scenario is you're going to have to move the wires around, but it's always nice to get it right the first time. So there's our new 470 ohm screen resistor, and it is going from pin 6 to 4. Pin 4 is actually the screen input to the tube. Pin 6 is just the landing spot for the screen voltage that's coming off the power supply. Okay? And you'll notice that I do not pull this resistor tight against the socket. You'll see that on a lot of the amps. I don't like to do that because it makes it difficult to probe or do any work in this area. Okay? So I don't like to choke off the bottom of the tube socket. You'll see I did the same thing with the grid resistor. He's kind of elevated. The reason for that is the heat that's rising up off that tube. I really don't want it to attack the resistor. And it gives you access to the pins. Alright, let's get the filaments hooked up. So when I get done with these wiring jobs, I always take a magnifying glass, carefully inspect all my connections, make sure I didn't miss anything, and of course make sure I hooked up to the right leads. Yeah, so that one looks good. Let's get this one out and repeat the process. So remember I stated that there had been some evidence of arcing back here. Well, look at these filament leads. That guy's been super hot. The insulation's peeled back on this one. I don't know what was going on, but I'm going to put some heat shrink tubing on these to protect them before I hook them back up. I've got all the wiring complete. What I'm going to do now is bring up the amp on my Variac. Just want to see the power light coming on. We got filaments. Put her at about 50 volts input, but all I'm really interested in right now, yes, the high voltage is off, is to make sure we got negative bias to pin 5, which is the grids. It's very important. Alright, we're ready to pop in some tubes, fire it up into a dummy load. Here we go. We're going to set the bias once again. Bring her up on the Variac. I've already throttled the bias all the way back. Okay, so it's putting maximum negative bias on the grids of these tubes to restrict the current flow. Just want to make sure that I start seeing some current showing up on this meter. I'm looking across one of the 1 ohm resistors to ground. We're on the volts millivolt scale. Here she comes. Alright, so I should be able to adjust bias. You see I can increase it and decrease it, so that's good. So right now I'm at about 80 volts input. So there's 100 volts input. I'm going to set these for approximately 28 to 30 milliamps when she's fully powered up. So we're looking good. Alright, we're going to go to full line voltage. And yes, I'm leaving the standby switch on. Okay, here we go. Full power. Let her stabilize. It's not going to take much adjustment here to bring these up to where I want them. There we are. Now these are new tubes, so the bias is going to vary. I want to give this thing a little bit of a burn in. So if I set this guy, say at 29 to 30 milliamps, if I go over to this one, I would hope to see about the same. So that one's a little bit lower. This was a matched pair. There will always be a slight difference, but that could also change after the amp cooks for a while. Alright, here's the true test. I got my audio generator set up over here. Go into the input of one channel. I'm going to bring up the volume control, take a look at the output on the scope. There she is. The tone controls. Good deal. Let's go over to the other channel. Not too easy to do when you got a camera in your hand. Alright, other channel. Here we are. Look there. So the amp is working great. I'm going to let it sit here and bake and recheck the bias. Well, I'm absolutely sure that the problem with the Bassman blowing output tubes has been solved. It was those old wore out tube sockets. I'm getting quite a few amps through here lately that have that same problem. Remember, they're 50 years old. It's a friction fit. Over time, they loosen. You lose negative bias, bam, takes out your output tubes, and worst case, it could take out your output transformer due to the overcurrent. So he got lucky, okay? The other thing that I really enjoyed about this repair was having a stable work platform. The old homebrewer did fine for me, but at times I didn't have it tightened enough, and I actually had amps slipping off of it, and I grabbed them, okay? But I thought to myself, just think, if that vintage amp had slipped off and hit the floor, bent the chassis, smashed the controls, etc., that'd be on me, right guys? So don't be like Elmer at Elmer's Paint and TV. Don't put your amp up on a paint bucket and work on it. Get yourself one of these stands. I'm not saying this because Mojo sent it to me. I'm saying it because it's a good investment and it's good for your shop's reputation.